Hello and welcome to Advantech Embedded Talk. I'm Stephen Liu. This Embedded Talk series features interviews and talks given by industry experts in and out of Advantech across the globe, with a special focus on key technologies and use cases found in emerging applications. We probe into certain vertical markets such as EV charging, robot AMR, low-speed autonomous driving, and ruggedized edge computers from an embedded systems perspective, which includes embedded hardware and, of course, software and security. This episode is about embedded software and security. I will be talking about the common challenges from the field and Advantech's coping strategies. I will explain how you can meet certain tricky requirements by IEC 62443 and other security standards using some handy tools. Advantech is home to over 100 embedded software engineers. They work to improve the efficiency, reliability, and security of IoT and edge devices. Over the past year, the team have got numerous inquiries of security solutions from equipment makers, system integrators, and operators of critical infrastructure, like smart grid and, in particular, EV charging facilities. All of them ask about protection at the lower level of embedded systems. Now, the number of EV chargers are growing in hundreds every day, everywhere. Concerns over security threats are reasonable and obvious. With ever more need for computation and communication, EV supply equipment, or EVSE, is highly vulnerable to a single point of infiltration that could cause cascading failure to the entire electrical grid. The demand for protection is now ever more urgent due to unstable geopolitics. I read one article on the Economist newspaper recently. It wrote, quote, "Grids have long been targets in times of war. Ukraine has been pummeled by Russian missiles and shells. They are also attractive targets for cyber attacks." Quote. To respond, regulators around the world have been demanding comprehensive security protection for mission-critical systems and infrastructure like medical devices, railway systems, utility, and of course, electrical grid and EV charging facilities. They tend to refer to ISA IEC 62443 as the overarching standard. IEC 62443 has become the golden sample or benchmark as many countries are introducing their own national standards and policies. Securing IoT devices, or more generally, operational technology or OT environment, is far trickier than protecting personal computers, mobile devices, or the IT environment. The main reason is stickiness. IoT devices are distributed remotely. They stay there, unchanged, for 5 to 10 years. And once deployed, it's hard to get them back for maintenance. That is why, if you read through the documents, you will find a significant portion starts with protecting at low-level embedded systems, which provides a more solid and sustainable shield to various types of threats. So what are they? What are those threats? The first nightmare is a kind of deep fake of your device identity. The computer is well functioning, but you lose control over it because somebody hacks into it and replace your firmware or BIOS with a fake one, or even replace the entire operating system with an unauthorized distribution. To prevent this from happening, make sure you've got secure boot process on x86 platform, plus boot guard technology if you are using Intel chips. It's called trusted boot on RISC computers. Anyway, this process involves a chain of trust that verifies each step of the booting sequence. You should definitely include a trusted platform module or TPM chipset on board the edge device. This TPM can store certain keys for identity authentication. One example is to ensure the integrity of the booting process and prevent most offline physical attacks and malware by BitLocker and TPM. BitLocker is a Windows feature that provides encryption to the disk volumes, and TPM is used to decrypt the disk volumes. Without TPM, you'll have to store a key to BitLocker elsewhere in less controllable environment. Another example of TPM is a secure onboarding and provisioning process for your IoT devices during the deployment stage. Suppose your products, say EV chargers, are sold to charge point operators or CPOs, who will then install the equipment to many different charging stations. How would you make sure that the onboard controller is still valid? What you should do is to get a certificate authority or CA from a trusted third party and write that credential onto the TPM. Next, configure the computer to your device management system somewhere out there on the cloud before shipment. Now, when your charge point operator or customer gets the EV charger, all they need to do is to power it on and connect it to the internet, and then the computer or the controller board will automatically register the certificate authority previously stored in the TPM and then be provisioned by your device management platform, whatever that is. Once your EV chargers are put into daily operation, it must be constantly updated. You may need to update BIOS, firmware, driver, the software, or even an AI model on top of it. So it's imperative to have secure over-the-air update mechanism. Advantech has a ready software for that called DeviceOn. DeviceOn utilizes X.509 certificates to authenticate edge device. It provides a ready OTA module and uses digital signature and MD5 file checksum to ensure the authenticity and integrity of the update. Yet, the most important update is probably security patches of the operating systems. It's not once and for all. You can't perform it on a regular basis. In fact, OS maintenance is a long-term commitment. It requires a dedicated team. Fortunately, you can rely on OS providers to do the job. Both Microsoft and Canonical offer up to 10-year support for Windows, IoT, and Ubuntu. These long-term support OS would really alleviate your burden. These are the most common challenges faced by EVSE makers. For more information about the solutions and how they help meet IEC 62443 requirements, you can download a playbook from the link below. Do let us know what you think about this issue. Thank you and goodbye.